Welcome viewers. We are going to see now today about the binary search tree. Now, how we are going to create a binary search tree and how we display the binary search tree we are going to see now. Now, here a single node of a binary tree is having one value part, another one two location storage as left and right. So the left and right is used for connect with left child and right child, left child and right child. So a binary search tree is having having maximum one left child and right child. The left child may be empty, right child may be empty, or left child is having some data, right side is having some data. So that one here. Now the binary search tree is having the value, any one of that field value you refer, then that value of root node or parent node is greater than the left child and lesser or equal than right child. So this is the binary search tree. Now here how we can create a single node. A single node is here we are having now that node is a class. In that class that constructor as init is here we are going to create one, right? Now this init, right, this init is having that one field is value, then another field is left and right. So here we are having this is left and that one is right, left and right. Okay. So here this is the node. So this class name is node. So node is here we are having that refer node. Then here we are having that value field is this one. Now this one is here we are having now left. Then this one is here we are having now right. Right. So here this is left right. Now initially while creating now the left child and right child is none. None is here. There is no reference for left and right. So left and right is empty. So that is none. Nothing is there. So while creating a node, the node is having that what value you are creating a node with what value, and that value is storing that field as value. Then another two field as left and right is none. So while creating a single node, so how do you create now? Using that class name, you are creating a node, right? You are creating a node. Here, for example, here you see this one node of some value, Then for that value, it will create a single node. I will tell that one, right? So this is the case we are creating now, right? So now here, this is for a template for that particular class. So it will create a single node with that whatever value we are giving now that one, right? So here for here you are having the main code is this one, n equal to end of input. Now I am going to give that input is 4 2 3 1 6 5 7. So this is I am going to give now that 4 5 6 7 is going to have as an array. So array of 0 is 4, and array of 1 is 2, array of 2 is 3, array of 4 is 1, then 5 6 7. So we are having now around 7 nodes, right? So array of 0 6 0 to 6. Okay, here we are having the node we are creating. So this is it is creating a list with that you are giving that input is in that sequence, right? Without comma you have to give 4 space 2 space 3 space 1, then here we are going space 6 space 5 space 7. So this is the input we have to give on that keyboard, right? So here we are having now that one as here what we actually we are having now that one as it's not there. Okay, don't worry. Right. Now you see this one here, this is the sequence we are giving now. Now what it will happen here? Now it will create an array. It will create an array. So this array is creating now with array of 0 is this one, 1, 2, 3, 4, 5, 6. So here we are having now, this is the index. Right. Now here it is creating that one as in that array with that value, right? So here we are having array of 0 is this one, 0, 1, 2, 3, 4, 5, 6. So this is the array ARR, that one. Now here a node of that array of 0. So first it is creating a node 4, right? The node 4, what it will do now? Here 4. So initially 4, so it will place that value 4 because of that value equal to self value. So self is that variable refer the initial node. So it will create a node. On that node, that value equal to 4. So this is a self dot value. So this is a self dot value is assigning that whatever value we are passing. So we are passing 4. So passing 4 is here. The self is refer the self node. So this node. So we are having that value equal to 4. The 4 is going to be assigned here. So that value of self value of that 4 is placed here. Now the left is null. So left is going to have null. Right also going to have null. None. So this is none equal to left, none equal. So this is creating now, and it is assigning to root. So what it will do now? Root is a reference. That reference is referring that node with value 4, and left is null and right is null. Nothing is there currently. So now a tree is creating with a single node. The node is root. Next we are having now, this is in that for loop we are having now. So this is inserting. Now we are inserting node 2. Node 2 is going to be insert now. So because of this one, so here node 2 with that root reference. With that root reference we are inserting. So here now the current node is here root. Current node is root. Root as reference. Now we are passing a value 2. So that node is going to be insert. Now current node equal to none. So here current node is having something. Root is having node 4. So the first condition is not satisfied. Now it will check now the value of current node value. So current node value is 4. Current node value 4 is referring current value. Current value is 2. 2 is less than 4. This condition is satisfied. Then what it will do now? The current node left. Current node left is this is current node. Current node left is this one. So current node left is high. Now we are having null. So current node left equal to current node left. This is none. With here we are sending that value 2. So now this value 2, so what it will do now is self dot insert, right? So insert is coming to, once again we are calling that same function self dot insert. Then here current node is none. Then here we are having that value. So here none. This condition is satisfied. Now it will create a node for our value. So value 2. For that value 2, it is creating a node, and that current node is assigning now that one. So current node is here, current node left. So that value is having that going to return to here. So current node left. So it is creating a node 2 with its left, right or null, and this node is going to be assigned to current this root left. So how it is root left? So current node left is we are calling current node left. So current node left is this one is. So here it is making a link. So it is creating one node and join. Now next we are having 3. It will call that one. So calling that function with current value is 3. So 3 is going to come now. Then 3 is checking now. Then what it will happen here? From the root node we are starting now. So here we are inserting from root node. By referring from root node, we are calling now with 3. So now that value is 3. So it will come to here. It will check. Now it will go for the condition is here we are having 3 is less than. So it will come to here. Now this is not null. Now using this node, right? So here once again it will call that insert. Then insert is calling now the 2. 2 actually the current value is 3. This is 2. So it will call that one the current node right. So current node right is this is the current node now. The current node is this one. The current node right calling now because of this is actually 3 is greater than current node. So here it will call now current node write equal to self insert current node write of that value. So now that value is we are passing now 3. So it will passing now this 3. So it will create a new node, and its left is null, right is null with that value 3, and this node is assigned to this current node right. So we are having a link. This is the link. So it will come out. Next we are having now, we are calling with that value 1. Calling with value 1. So it will come from the root because of this calling. So come from the root. So this is less. It will come to here. Now for the 2, this is less. Now it will call that function with the current node left. Current node left is calling that one with value 1. So now it is creating a node with value 1, then its left right null, and this node is assigned to the current left. So we are having a link. Next we are having now that value 6. 6 is greater than 4. Now it will call that function with that root node with right. Now right, then here we are having now nothing is there. So it is creating a node 6, and its left right is null, and this is assigned to. Then here we are having 5. So it will come from the root. 4 is compared with 5 is a greater than that one. So it will come to here. 6, the 5 is less than that one. So we are creating a node 5, and this is connect with that left 5. Then we are having 7. So here 4 less greater than 4, 7 is greater than 4. It will come to right. Then here 7 is greater than 6. It come to right. So it will create a node 7, and its left right is null, then it will join with that. Now this is the tree creation. So here we are having that one, it will create the tree. So in that for loop we are calling one by one, then we are making a link with that node. So we are having a tree. Now the current tree is here 4, 2, this is 3, this is 1, this is 1, this is 2, this is 6, this is 5, this is 7, right? These are all the child node. So this is the root. Now for printing, so we want to print the content, right? So here it will come to here print tree. So here what it will do now, then print tree is calling now with that print tree. So here root dot print tree, we are calling that function with the root. So we are calling that print function starting from that root node. Starting from that root node, then here what it will do now, self dot left print tree. So once again we are calling that same function as a recursive function. We are calling that same function with this one print tree, right? Then it will come to have that is left. Then from that left we are having another tree, so it will come to that one. Then here we are having there is no left. There is no left. So this in that node 1 there is no left. Then what it will do now? It will print dot self value. So it will print that value 1. 1 is printing now. Then what will happen here after printing? Then what it will call now? Well, the right. So self right is here nothing. The self node right is nothing. Then what it will do now? Then it will come out. Then here you are having now the return back to this node. Return back to this node. So this one is here we are having now return. So it will print the current value is 2. After printing 2, what will happen here? It will call that self right. So self is this one. In that self right we are having some node. Then it will come to here. Then here we are calling once again the self right, but the self right is null. Self right is here null. So here what it will happen here now? Here self right is null. So this one is it will print now. So this one is we are having now left right is null. Left right is null. So it will print. So now it will print value 3. Then after that it will return back 3, return back to 2, then return back to 4. Now it will print that value 4. In that way, then next it will go for print right, then it will call that right. So from that node, current node is this one, then it will call that right, then from that right it will go for left. Because of that right is calling now, then it will call its left, then it will come to here, and here in that left is null, so it will come, it will print that 5. So 5 is printing now, then it will return back to 6, so 6 is printing now. Then after that, then its right is calling now, then here left is null, right is null, so it will print 7. The 7 is printing now, and it will call back that left is null, so it will return back and return back to come out of that one. So this print function, call this function. This function is a recursive function from left to right. Then it will print from the, it will call from here to the leftmost and then come back. Leftmost is printing now, then come back it parent, it will print, then it's right, then there is no leftmost, nothing, there is no right, here it will print 3, then right is nothing, then it will return back and return back to 4. Now it will print 4, then after that it will call right, the right it will go to left, then the leftmost is null, so it will print 5, then it will check that left, right, nothing is there, then it will return, then it will print 6, then it will call that right, then here left is nothing, then it will print, then here right is nothing, and then it will return back to here. Okay, that's all that tree creation and tree display. By next lecture we are going to see how to delete a node from the binary search tree. We are going to see, right? Okay, if any doubts you can give the comments, right? Comments are welcome, then I will explain that one. Thank you.